Hey everybody, welcome to another edition of Mr. Monroe's Math. As you can see here, math is fun. It is a function of u to the nth power. Let's have a little fun here. This is lesson 31 from Module 4 with expressions and equations. Now I'm out today, so please be good for the sub and follow along right with your notes. You have this on your paper. It is right there. Let's read it together. Marcus reads for 30 minutes each night. He wants to determine the total number of minutes that he will read over the course of a month. He wrote the equation t equals 30d to represent the total amount of time that he has spent reading, where t represents the total number of minutes read and d represents the number of days that he read during the month. Determine which variable is independent and which is dependent, and then to create a table to show how many minutes that he has read in the first 7 days. So first of all, we're talking about 7 days. Now, you may or may not have already talked about independent and dependent variables, but we'll get to that in a moment. So let's set up this table first of all. We need two categories, okay? First one that we're going to have is the number of days. We'll call that D. And the total number of minutes read. Okay, so we're reading that book and we're reading 30 minutes a day, and hopefully we're doing that now too. It's very important. Independent versus dependent. The definition here is independent, anything that cannot be affected by another value. So for example, time. Time keeps on ticking, ticking, ticking into the future. Okay, you get the point. So independent variable, it keeps ticking no matter what. We can't stop time. Now we may have a clock that we can pull the battery out of. That'll stop it, but time keeps ticking. So independent variables are going to be matter of time or something that cannot be changed or altered. Okay, so on the independent variable here, we're going to put the number of days. Okay, now you may say to yourself, why not minutes? Now minutes read, so the action that we're doing is reading. So the dependent variable here, okay, is going to be the total minutes, or the number of minutes read. And that's the key part here, that we're reading in the days allowed. So we're going to find out what each day here represents. So on day 1, okay, this equation here, t equals 30d, the amount of time spent is 30 minutes, okay, times the number of days, and that's what's affecting it too. So 30. So on day 1, it would be 30 times 1. Okay, or 30 times the number of days here. If it's 1, it equals 30. Okay, and this minutes read, we're going to call that in 30d here. What about day 2? Day 2, 2 times, all right, how about you? Why don't you answer? Yeah, 60 minutes. Okay, day 3, 4, 5, 6, and 7. Okay, we fill in a value here. Random one. 5th day, 5 times 30, in the back. 150, very good. It's the same as 5 times 3. Okay, so that's the idea for 1. Fill out the rest of these values, please. You should know what those are. Okay, so as we keep going, getting this idea, that's example 1. Get your highlighters out, please. And highlight example 2. That's the next one here. Example 2. Okay, let's get to this point. Highlight it right here. Very important that we get to this, because we're also dealing with the equation of it all. Okay, the equation. Okay, let's read it together. Kira designs websites. She can create 3 different websites each week. Kira wants to create an equation that will give her the total number of minutes she can design given the number of weeks that she works. Determine the independent and dependent variables. So again, independent is what cannot be affected or changed or altered. Okay, good vocab word for you, altered. Create a table to show the number of websites, our table is there, that she can design over the first 5 weeks. So that's going to be one of our categories is the weeks. And then finally, to create an equation now. Create an equation to represent the number of websites that she can design when given any number of weeks. So maybe it's the 10th week or the 12th week. It doesn't matter. So, independent variable, what is not being affected here? It is the weeks. Okay? So the number of weeks Okay? We want to call it worked, we can call it whatever. Let's call it worked. Okay? So I'll say weeks here. Weeks worked. Let's give that a variable. Let's give it, let me say W. Let's give it W. So categorize that. And then the dependent variable right here. Dependent variable is going to be, okay, the number of websites designed. Now, websites, you would think to do a W again, but we can't use a W again for a variable because we used it already. So we're going to use D for design. So we can say websites designed. And we're not graphing this yet, but we'll get there. And what we can think about doing is your independent variable is always going to be on your x-axis. So think about your x and y coordinates and how we could possibly graph those. That'll be a look into the future right there. Okay? Your independent variable should always be on the x-axis. Let's make a mark of that right now. Okay? That'll be on the x-axis, and we'll get to that later on in the future. Okay, so keep going. For the first 5 weeks, so we want to list right through here weeks 1 through 5, and look at that, we have enough room. Week 1, 2, 3, 4, 5. Can you tell it's almost St. Patty's Day? We've got our green on, green marker, having some fun here, because math is fun. Okay, let's go. We've got to come up with an equation. What can happen every single week? One-step equation. So equal sign. Okay, so with an equal sign, the amount of websites, well, we got to give that a letter. We gave it D. I just didn't write it yet. Okay? Websites designed. So the amount of websites equals, well, how much does she make per week? Okay? What does it say here? What does it say here? 3. 3 different websites. So 3 websites each week. So in week 1, that's 3. What about week 2? 2 times 3, 6. Okay? Keep going through the rest of that. So we have our D equals 3W. Now I asked you a question. What if we had 12 weeks that she worked? How many websites? Okay? Figure that out. So, you're with me here? Keep going, keep going. We're going to get on to example 3 and definitely highlight this one. This will be the last one that we do together. Okay, last one here. So we've done a setup of a table, we've done a one-step equation, now we're going to talk about a two-step equation. Let's read along. Priya streams movies through a company that charges her a $5 monthly fee plus $1.50 per movie. Determine the independent and dependent variables, write an equation to model the situation, and create a table to show the total cost per month given that she might stream between 4 and 10 movies. Be careful, we're not dealing with 1, 2, or 3. We're starting at 4. So between 4 and 10. So we're going to mark that right now. Okay. What is the independent variable here since we're not dealing with time? Okay. The amount of movies per month. What do we see there? We see a ratio back into play again. Okay? And the dependent variable, well, it's going to be the total cost. We've got to find out just how much money it's going to be for the course of the month. Okay? How much we're going to make here. So we need to label this. Independent variable we'll start with movies. Think about your favorite movie real quick. And why don't we say the cost? So movies M. And how about the cost in dollars? Let's give that a variable. What do we want to give it? Cost. Let's go with C. We'll go with that one. Okay? So in dollars, money sign, number of movies, okay, for 4 through 10. So what's an equation we can come up with? Something with an equal sign for sure, okay? And what we want to talk about here is there's also a $5 monthly fee, okay? So that monthly fee has to be added on afterwards. Now, how much does it cost per movie? Okay, so the total cost is going to equal, and typically what we're doing is we're multiplying, or whatever the operation is, with the independent variable. How does that affect the change or the elevation depending on the y-axis? So again, we're going to put all that together very soon. So we have $1.50 per movie, M, okay, plus $5. All right, so let's determine that for 4 through 10. So let's start with 4. 150 times 4, and again, just like the order of operations, we're solving this multiplying first before adding. So 4 times $1.50, think about it, $1.50, 3, 4.50, $6. So 6 plus 5 equals, well, the cost is going to equal $11, and that's for the fourth one. So what is the trick here? What are we doing for each movie? There's a $5 fee for the month no matter what. It's already fixed into this equation. What about movie number 5? Each one costs $1.50 per movie. So we can increase by $1.50. Makes our life a lot easier. Just add $1.50 to the next movie. So 5 movies, $12.50. And keep going through that until you get all the way to the 10th movie. In the 10th movie, we will get $20. Okay? So you're going to do the next several examples here, and you will have a homework assignment tonight. You are going to do the problem set for 31. I know we've skipped now 2 lessons. We're coming back to it because seeing this first will help those other lessons make it that much easier. Okay, so why don't you go ahead and do exercises 1, 2, 3, and 4. Show that to the front when you are done, so you can pick up the problem set and you can start that in class. All right, so again, remember, independent and dependent variables. Independent variable cannot be affected. It's typically time, which will go on the x-axis, and we'll get to that more later on. The dependent variable, and here we have a 2-step equation. Last one we had a 1-step equation, and then we're going to go from there. So, keep it up. Math is fun, remember that. Have fun with this, ask questions, and good luck.